All right, let's review for the test together here on polynomials. Name each polynomial by degree and number of terms. So the degree is the biggest exponent. The biggest one is 3, so we call it a cubic. How many terms we have is 3, so we call it a trinomial. Here, the biggest exponent, I don't see the number, but the number I don't see is 1. So when that is true, it's called a linear, and there's 2 terms, so that's called a binomial. To simplify this, we just have to match and combine like terms. I want you to start with the ones the biggest exponent, and then match it, and then can you add it together? That's 1x to the 4th. You can then cross it out. The next is 3x cubed and 6x cubed. That's 9x cubed. And then what's left? And again, if you cross it out, 2x and 8x, that's 10x. Subtracting is a little more complicated, but not too bad. So again, start with the ones with the largest exponent. So 8. Now when you subtract a negative, you're adding, so that's 13. 5n squared, subtract 7, that's negative 2n squared. And then 7 take away 4 is 3. All right, we're going to find all zeros by factoring here. So there's 4 terms. So I'm going to factor out what they have in common. So they have a 7v squared. And then divide, I'm left with 3v plus 4. The next two, it's a negative 5, and then divide, that's 3v plus 4. So I have 7v squared minus 5. I have 3v plus 4. Now 7v squared minus 5, I make equal to 0 and solve it. So I'm going to add 5 and divide by 7. When I square root this, the answer is going to be both positive and negative, and you can leave the answer just like that. The second one answer, the second factor, you're going to subtract 4 and divide by 3. And those are your zeros. These are 2 irrational, and that's 1 rational. All right, we're going to factor it. Factor out a 3n squared and then divide. Factor out a negative 8 and divide. So we have 3n squared minus 8 and 3n plus 1. If I take 3n squared minus 8 equal to 0 and solve it, I would add 8, divide by 3, and I would square root. And that's positive and negative. If I look here, I would subtract 1 and divide by 3, and those are my zeros. Factor, that's going to be a squared minus 10 and a squared plus 3. So the two numbers that multiply to negative 30 and add to negative 7. Take each one equal to 0 and solve it. And so one answer is going to be plus or minus the square root of 10. And the other answer, when I subtract 3, you got to be a little more careful here. So it's going to be the square root of a negative number. So the square root of a negative number is imaginary, then root 3. So these are your zeros. Plus and minus root 10 and plus and minus I root 3. All right, factor this. That's x squared minus 9 and x squared plus 5. Now x squared subtract 9 is a difference of squares, so it can be factored further, but not x squared plus 5. If I take x squared plus 5 by itself, make it equal to 0 and solve it, I would subtract 5. When I square root a negative number, the answer is positive or negative. Square root of a negative number is imaginary, and the square root of 5 is just root 5. So if I would summarize the zeros, it would be positive and negative 3, and then positive and negative I root 5. All right, factor this one. Oh, just an x. And then x squared minus 5 is a difference of squares. And then the zeros. Be careful here. When it's just x, the 0 is 0, and then positive and negative 5. All right, factor out an x. You have x squared plus x minus 2. Continue to factor. That's positive 2 and negative 1. And now the zeros that come from that, so that'd be 0, negative 2, and 1. So 0, negative 2, and 1. Divide. If it's a simple divisor, simple linear, then I'm going to use synthetic. Make sure I did it right. And then once you do that, then I'm going to write the answer above here. So because it's a 3, the degree, our answer is going to start with 1 degree less. So it's going to be a 2. So it's going to be 1v squared, then minus 8v, then plus 5, and then positive 2 is the remainder. Draw a fraction. The 2 goes on top, and our divisor goes underneath. All right, try number 12. So I have 2. Make sure you use the 0. So it's positive 2, and then negative 3, 7, 5, and negative 23. So if you want, you can start with a 0, add, and then multiply, add, and then multiply, multiply. This can be a negative answer at the end. And then how do I write that answer? So it's going to start with squared. So negative 3m squared, then 1m, then plus 7, then subtract a fraction, and the 9, and then underneath is m minus 2. Number 13, we're going to start with negative 10. And I have 1, 19, 88, and negative 26. If you want to start with a 0, you can. You're adding and then multiplying. So the remainder there is negative 6. So my answer is going to start again with squared. So it's 1m squared plus 9m minus 2, and then the remainder. Subtract fraction 6, and then m plus 10 on the bottom. Number 14. Again, I'm going to use positive 8. And then 1, 2, negative 79, and negative 17. So this is 1, that's 8, that's 16. Nope, that's 10. Haha. 8 times 10 is 80. That's 1, and then 8, and then the remainder is negative 9. So that would be 1k squared, 10k plus 1 minus, and then 9 over k minus 8. Now, this is no longer a simple divisor, so I have to use long division. I need to be careful there's no missing powers. There's no missing powers. And then divide. So just take the power term divided by the power term. So 3 divided by 3 is 1. And then 4 subtract 1 gives me x cubed. And now I multiply. So x cubed times 3x, x cubed times negative 7, and then subtract. Be careful, when you subtract a negative, you're adding. So it's negative 13 plus 7. And then bring down the next term, which is 26. Again, take the power term of the remainder. So negative 6 divided by 3, subtract the exponents, multiply. That's going to be a positive 14. Subtract. That remainder is 12. Bring down the next term. Again, we're going to go 12 divided by 3. That's 4. Subtract the exponents. Multiply. That's 12x squared. 4x times 7. And now be careful when you subtract. When you subtract a negative, you're adding. So it's negative 19 plus 28. That's 9. Bring down the last term, which is 24. 9 divided by 3, which is 3. That gives me 9x and negative 21. Be careful. So when you subtract a negative, you're adding. So it's negative 24 plus 21. And then that's the remainder. So the remainder gets written as a fraction, where the 3 is on top, and then 3x minus 7 is on the bottom. And then your answer is on top here. All right, one more. Long division. Write it out. You might have to put a 0 there, but let's see what happens. So divide the power terms, and you get 1v to the 3, and then you multiply. And what happens here is when you subtract, you have no remainder. So with no remainder, I just bring down the last two terms and then use it. So now the power term divided by the power term, negative 5 divided by 5 is negative 1. The v's divide out. Multiply times negative 1. Be careful when you subtract. So when you subtract a negative, you're adding. So negative 8 plus 2. And then that's the remainder. So 6 on top and then 5v plus 2 on the bottom. Number 17, when you ask to solve an equation equal to 0, it's just asking for the zeros. So we're going to factor this. We're going to factor out an x to the 4th and a negative 1. So I start with factoring. And so I have x squared minus 2 and x to the 4th minus 1. X to the 4th, subtract 1, is a difference of squares. So you square root. Now the square root of x to the 4th, you take the exponent and divide it by 2. So it becomes x squared plus 1 and x squared minus 1. So all of these are going to give solutions. So x squared minus 2, x squared plus 1, and x squared minus 1. All of them are going to give you answers to your solution. So here, I'm going to add 2 and square root it. So two solutions are positive and negative root 2. I'm going to subtract 1 and square root it. So plus and minus. The square root of negative 1 is I, imaginary. And then again, I'm going to add 1 and square root. And then my last two solutions are positive and negative 1. I want you to notice that you have a degree of 6, and you have 6 solutions. And there they are. Here again, number 18. We're going to start by factoring. So look at the first two terms. They have x to the 4th in common. That's x squared plus 4. Factor a negative 1. Again, it's x squared plus 4. We just did x to the 4th minus 1. So we know that's factorable by a difference of squares. X squared plus 4 is not factorable. So this is x squared plus 1, x squared minus 1. And then we take each one of these factors equal to 0, and that gives me all the solutions. So if I subtract 1 and square root, that's going to be positive and negative I. If I add 1 and square root, that's just positive and negative 1. If I subtract 4 and square root, that's positive and negative. Now, the square root of a negative number is imaginary, and the square root of 4 is 2. So put it together and it's 2i. And those are your 6 solutions. Turn the page. All right, power term and end behavior. So the power term is negative x cubed, which means the right end is going down and the left end is going up. Make sure you know the notation in terms of how to do it. But this says the right end goes down and the left end goes up. Here the power term is x to the 4th. That means it's positive with an even exponent. So the right end goes up and the left end goes up. And again, be comfortable with the notation that we're using. Here the power term is negative x to the 4th. So then both ends go down. So the left end and the right end go down. Both ends go down. For 22, the power term is x cubed. So it's positive with an odd exponent. So the right end goes up and the left end goes down. And that's the notation to do the end behavior. Next, can you graph a polynomial? So what am I looking for? I'm looking for zeros and I'm looking for end behavior. So I just did end behavior. So this tells me the right end goes up and the left end goes down. To find the zeros, I'm going to factor it. So I'm going to factor out an x squared. And so each factor gives me a 0. So x squared, it's 0. And x minus 3, it's 3. Those are your zeros, and I know the right end goes up and the left end goes down. I want to find a turning point here, so I'm going to pick 1 or 2. Doesn't really matter. If I pick 1 cubed minus 3 times 1 squared, that's 1, take away 3, which is negative 2. I can use that. If you wanted to pick the next number beside it, which is 2, it would be 2 cubed minus 3 times 2 squared. That's 8, take away 12, which is negative 4. So that one's a little lower. And then connect, and then make your graph. So I put it at negative 4. The other one's at negative 2. I need a little water. Number 24. We're going to factor it to begin with. Now, this one's a fun one to factor. So, truth is, the first thing I would do is I would factor, first of all, negative x to the fourth means both ends are going down. I want to factor to find the zeros. I want to factor out a negative to make it easier. So that's going to be x to the fourth minus 2x squared plus 1. And then what two numbers multiply to 1 and add to negative 2? That's going to be negative 1 and negative 1. And then this is a difference of squares. So x plus 1, x minus 1, x plus 1, x minus 1. And then match them up. So I have x plus 1 squared. I have x minus 1 squared. So what are my zeros? So it's at negative 1 and positive 1. I know both ends go down. If I plug in 0 for x, the y-intercept is at negative 1, and I'm going to use that as a turning point. And then I connect the points together, and I've drawn my graph. All right, last one here. So it's not factorable. So I'm going to do a list because I need to factor it. I know the y-intercept's at 4. That's helpful. I know the right end goes up and the left end goes down. That's helpful. Negative 3, 0. Don't forget that missing term. And I need to know what number is going evenly. So not 1, 2 maybe. Let's try 2. So 2 goes into it evenly. What's left is x squared minus x minus 2. That is negative 2 and positive 1. Now, this is also x minus 2, right, if you change it into a factor. So this is really x minus 2 squared, x plus 1, and we factored it. So at positive 2, it bounces, it doesn't cross over. And then we have one at negative 1, and there you go. So we know the right end goes up, it touches, goes through the y-intercept, and then the left end goes down. And that's it. And you graphed it. I'm looking at the end behavior and the intercepts and putting it together. And if you need to find another point for a turning point, that you can just plug in and find that turning point. All right, next page. Where's the next page? All right, end part. Oh, it's on the back side. Huh? Here it is. All right, state the possible rational zeros and then find all the zeros. So ultimately, I just want you to find all the zeros. If you can factor it, do it. If you need to create a list, then you do it. Fair enough. So I can factor this. So I'm going to factor out an x squared. That's 2x plus 1. I'm going to factor out a negative 1. That's 2x plus 1. So when I put it together, I have x squared minus 1 and 2x plus 1. And then x squared subtract 1 is a difference of squares. And then I get to my goal. So my goal was to find the zeros. So what are the zeros? And these are rational, are negative 1, positive 1, and negative 1 over 2. Okay? So if we can factor it, that's what I want you to do. So I can factor it. X squared, that's 5x minus 1. Negative 1, that's 5x minus 1. So I have x squared minus 1 and 5x minus 1, and then factor it. And then once it's completely factored, each factor gives you a 0. So it's positive and negative 1 and positive 1 over 5. Number 28. Again, I want you to factor it if you can. This one I'm not sure. Is it factorable, this one? I don't think it's factorable. All right. It's not factorable. So instead, if I just create a list from here, I'm going to tell you a quick way to do this, because this is what I notice. What happens when you add 5 and negative 31, 31 and negative 5? So obviously it's 0 and 0. It adds up to 0. So positive 1 is a 0. Wait a second. Sorry. Negative 31 and 5. Negative 26. All right. And now what I'm left with is 5x squared minus 26x plus 5. So what's left is factorable. So I found a 0. How do I find the rest of the zeros? So 5 times 5 is 25 and negative 26. What two numbers multiply to 25 and they add to negative 26? So it's negative 1 and negative 25. Now I'm going to show you another way to do this. Kind of a trick, a gimmick, which I don't like, but it makes it easier, so we're going to go through it. So negative 1, negative 25. Take the leading number, which is 5, and divide both numbers by that. So I take that leading number 5 and divide both numbers by 5, and this is called a slip and slide or something like that. You take the denominator and you slide it in front. That's 5x minus 1. 25 divided by 5 is 5, and it's done. That's another way to do it. And then the question was, once we have it, what are the zeros? That's my goal. So positive 1 over 5, and positive 5. All right, number 29. Positive 1 doesn't work. Do you think negative 1 might work? It does. So negative 1 is a 0. We're left with 2x squared plus x minus 1. Again, to factor this, 2 times negative 1 and positive 1, and those two numbers that fit, they multiply to negative 2 and they add to 1. So one is x plus 2, the other is x minus 1. Divide by 2. And so you have x 2 divided by 2 is 1, and then you can slide this in front if it doesn't divide, and that's 2x minus 1. And now the zeros. So we have negative 1, another negative 1, and then positive 1/2. And really, we don't need to write negative 1 down twice, so it's just negative 1 and 1/2. All right, we're almost there. Do you know how to write these polynomials? So if I give you the zeros, can you work backwards? So negative 1, positive 1. Remember, we do the opposite signs, right, for these. So can you take the 0 and write the factor that matches it, and then can you multiply it out? So this is a difference of squares. So x plus 1, x minus 1, it multiplies to x squared, take away 1. This you might need to FOIL. And then we multiply to find each squared. So multiply And then you have it. So we have x cubed minus 3x squared minus x plus 3. Done. All right, up with the next one. Negative 5, that's x plus 5. 0, that's just x, or x minus 0, which is x. And 4, which would be x minus 4. So I can multiply the first and last together and then multiply everything times x. So that's going to be x squared. 5 take away 4 is 1x. And then 5 times negative 4 is negative 20. And then multiply x, and you have x cubed plus x squared minus 20x. All right, what happens if it's imaginary? They always come in pairs. So if you have one, you got to write the other one. They're called conjugate pairs, where one's positive and one's negative. Put this here so they don't run into each other. So it's going to be x plus 5, and then x plus 2i, x minus 2i. So those conjugate pairs are a difference of squares. So x times x is x squared. Now 2i and negative 2i is negative 4i squared. But I want you to remember that I squared is negative 1. So a negative times a negative, this just becomes x squared plus 4. Then we can FOIL that out. So we have x plus 5, x squared plus 4, and then FOIL it out. So that's x cubed, 5x squared, 4x, and 20. And then you have your function. So we have x cubed plus 5x squared plus 4x plus 20. All right, number 33. So 4 is x minus 4. This one's actually going to be a negative 2. Well, let's change this. So negative 2 plus I. I'm going to make this a little bit easier. Okay? So I'm going to make this so this is negative 2, positive 2i, and then negative 2i because it needs that conjugate. That's going to make it easier. I'm going to do that for you instead of having it be a complex number. Okay, so this negative 2 becomes plus 2, and then 2i and minus 2i. And so we set it up. Here we have x squared, negative 4 plus 2 is negative 2x, and then negative 8. Here we have x squared. Remember, negative 2i and 2i is negative 4i squared, but the I squared makes the negative 4 into a plus 4. And then this is what I have to FOIL. So we have x squared minus 2x minus 8, x squared plus 4, and then FOIL it out. So it's x to the 4th minus 2x cubed minus 8x squared, 4x squared minus 8x minus 32. So now I'm put it together. X to the 4th minus, did I do that right? Yeah, minus 2x cubed, and then minus 4x squared when you combine like terms, minus 8x minus 32. All right, 2 left. So we have x plus x minus 1, x minus 4. And then when you have a fraction, it's going to be 5x plus 4. So you got to multiply by 5 and then add 4. So that's what matches that fraction. So this is going to be x squared minus 5x plus 4. So negative 1 and negative 4, and then multiply it. And then you can draw your box. And then multiply it out. So that's 5x cubed. That's negative 25x squared. That's 20x, 4x squared, negative 20x, and 16. So that gives you the answer. So it's 5x cubed. What is this? Negative 25 and 4. Negative 20 and 20 is 0, so it's just 16. All right, last one. So the first one is going to be 3x minus 2. And you can always work backwards. Would that give me positive 2/3, right? They match. And then x minus 2, x plus 1. This is going to be x squared. Negative 2 plus 1 is negative 1x, and negative 2 times 1 is negative 2. Draw your box. Run into each other here. So 3x minus 2, x squared minus x minus 2. Multiply it, 3x cubed minus 3x squared minus 6x minus 2x squared plus 2x plus 4. Combine like terms, then it's over. We got minus 5. We got minus 4. And then plus 4. That's it. Mr. G Math, over and out. Great job working, studying. Good luck on your test. Over and out. See you soon.